Hi guys, and welcome to HSC Chemistry and the final topic that you'll need to cover for your HSC, which is the option Industrial Chemistry. As this is the first one, we're going to do a quick overview of what's really the focus of this topic, and that's one of the things that I've talked to you guys about before, is making sure you're really clear about the focus of each of these topics and try and see the threads that run through each one. And then we'll have a quick look at a case study to finish this video. So I've just called this first one replacing natural products, and the focus really on the need for industrial processes in the first place. So what is industrial chemistry? Well, when we're looking at industrial chemistry, what we're looking at is the production of materials on a large scale. Okay, and generally speaking, most industries are set up and not for the benefit of the populace, but for the benefit of the owners of the company. So we want large-scale production and some commercial gain, so some profitability. We want to make sure that we're able to produce materials that are in high demand or short supply or both. So one or the other of these is very important, and if both are in play, then obviously you're going to have a very profitable company. One of the main things that we're doing though is we're looking at either producing materials that are as replacements of other materials, either by trying to come up with something that has similar properties, and we've looked at this already in other topics in chemistry so far, and we'll look at this in the next couple of slides. But you really are trying in an industrial process to produce something that's quick, that's efficient, and that's large scale. One example that we've looked at already in this course is the Haber process, and we looked at that in the last unit. And that was really about trying to solve a problem associated with the importation of nitrogen. And nitrogen-based compounds were very important, and particularly at a time where the embargo was on stopping a lot of traffic coming through into Germany, and therefore in order to feed the population and also to maintain their war effort, something had to be done in order to try and replace those nitrogen compounds. And of course, that's where Haber developed the Haber process. And we've looked at the fact that this is an equilibrium. We can monitor this process to identify that we're maximizing yields and ensuring the safest possible conditions as we can for those maximized yields. This was a big factor in the German war effort, and of course we've contextualized this process at the time of the First World War. It was the industrial, I guess the industrialization by Bosch who actually created the large-scale industry upon which Haber's process became so successful. So what we want to do is we want to have a bit of a look at how we replace natural products. The thing we're going to do is do a quick case study on rubber, and you need to keep in mind these important components when we look at this study, and that is that as society's demands increase, so we need to increase production. Now, if we have finite resources, then we may have to look at some sort of a replacement for those materials before they run out or before our demand exceeds the supply. We've done this with a couple of areas already. We've looked at the production of biopolymers and their potential to replace some of the materials that we produce from petrochemicals at this point in time. We've also looked at the potential of things like ethanol from fermentation to replace some of the fuels that we use as energy sources. But in addition to this, we also want to try and expand our range of different types of materials in order to continue to research into these areas. And that's why we've looked a little bit at this field of biopolymers. But the biopolymers that we've looked at so far is of just a very narrow range, and we need to expand this, of course, if we're going to continue to meet the growing needs of a very large population, global population. So that's what this is about then. We're going to investigate some important industrial processes, and those ones that have been chosen are really about the key chemicals that we need, that we use on a very large scale, and how those chemicals are being produced. So here's a quick case study then. When you're doing a case study, you just need to select one material that is not a fossil fuel that has been or has needed to be replaced at some point. So this one's going to focus on rubber. Synthetic rubber or neoprene, a version of some of the different synthetic polymers, are being produced now in order to replace the natural rubber, the rubber that grows on trees, basically. And that's often referred to as latex. This is a result of shrinking world resources. In fact, it's things like car tires that have expanded our need for rubber, and therefore the supply has dwindled as demand has massively increased. And this increase in demand puts pressure, particularly on chemists, to try to come up with a solution to this problem. Some of the benefits of synthetic material include the consistency of properties. So we can look at the rubber that grows on trees, obviously, may differ a little bit in its properties. When we're producing something synthetic, we know we can monitor the process, we can have exactly the mix that we want in that rubber, and we can be much more consistent in terms of its properties and what we want it to do. And also scalability. At the moment, the rubber trees are limited in where they grow. They grow in tropics, and so you must locate your rubber industries where your source material is and around those rubber plantations. But the expansion into more synthetic materials means you can have local sites. All countries, the access to petrochemicals is much larger, and so therefore we can have local sites. We don't have to have all the same issues associated with importing. Now, you don't have to do rubber as an example, but it's important that you select one example that you can use as to discuss in order, I guess, to look at how industrial processes can be used to solve problems of supply and demand. Thanks for watching.